Hello everyone, very good evening and welcome to the BYJU'S exam prep. This is Sanjay Rathi. Now, this is previous year question series means what? 2021, 2022, 2023 means last 3 years question paper. And we are going to discuss question from what? Network. And that is from electrical branch. Right? And then I will take one session on what? Electronics branch. And why we are solving these questions? Because it is based on what? Latest pattern last 3 years 23, 22 and 21, and you will get idea which type of questions they may ask, guys. Okay, so I'm just going to start my session, and then here we will solve some questions, and please note the topics, which topics are important, and try to solve this question. Okay, try to solve this question. Okay, then एंड यूज योर वर्चुअल कैलकुलेटर. फिजिकल कैलकुलेटर जो आपके पास अवेलेबल है उसे यूज मत कीजिए और स्क्रिबल पैड का भी यूज कीजिए. ओके, just in exam like environment we are going to solve some important questions here. This is my introduction. Myself Sanjay Rathi. I am an ex-IAS. I am having 22 years of teaching experience. Okay, and I have qualified and selected for engineering services exam. I have trained more than 1 lakh students for these competitive exams. Then this is my Telegram channel. Just after the session I will upload the PDF of this session on my Telegram channel. If you want to improve your concept, then you can join. If you want notification about other exams, then you can join my Telegram channel. That is Electronics by Sanjay Rathi. Now guys, this is I'm going to start with what? 2021. So 2021, which questions are important? That is the first one. Okay, tell me what is the answer for this one. What is the answer for this particular question? In the given circuit for voltage Vy, this is the voltage Vy, to be 0. If this Vy is 0, the value of beta should be rounded off to 2 decimal places. Right? It is a numerical answer type question. As you know, there are 3 types of questions: numerical answer type, MSQ and MCQs. Right? So this is a numerical answer type question. Simply you have to find the value of beta when Vy is 0. Right? Now if the Vy is 0, how you can solve this question? Right? Can you write a KCL or KVL and then watch this? Tell me what is the answer. Everyone try to solve this question. Okay, suppose Vy is 0, then you can make it what? 0. Okay, and then you can find Vx. Why? Because it is 0, it is 0, it is 6 volt. So what is the value of the Vx? Right? Now with the help of Vx you can find the what is the current here. So Vx minus 6 by 1, just apply the KCL at this node. This is called nodal analysis. Vx minus 6 by 1 plus Vx by 4 plus Vx by 2. You can take 4 as a LCM. Two Vx. 2 plus 1, 3 plus 7 Vx is equal to 24. You can check my calculation also. This is 4 Vx, this is 24. This is what Vx, and that is what 2 Vx, 2 plus 1, 3, and that is the 7 Vx is equal to 24. Then what is the Vx is equal to 24 by 7. Now, exactly what is the value of, once you will get the value of the Vx, so 24 by 7, this will become 24 by 7. Now you can apply 0 minus Vx by 2, Vy is 0. 0 minus Vx by 2 plus 0 minus P beta Vx by 3, and this is the, these are the outgoing current, and what is the incoming current? 2. You can take 6 as a LCM, then it will become minus 3 Vx minus 2 beta Vx is equal to 2. This will become 12. 6 into 2, 12. Minus 3Vx minus 2Vx beta is equal to 12. Now you can find the value of Vx from this formula, that is 24 by 7. You can put the value of Vx, right, and then get the common and you can find the value of beta. Is it clear? That is the way. Means to solve this question, simple, you have to apply what? Nodal or KCL at this node and at this node. Calculation is your part. You can do the calculation at the, I have the value of the Vx, put here, and then find the value of beta. You can also take what Vx as a common, then it will become is equal to 12 upon Vx, that is 12, this is the 24 by 7, 7 by 24, 3.5, and then from this you can find minus 3 minus 2 beta, 6.5 divided by 2, and you will get the value of beta here. Okay, so that is the way. Now next question, next one. Second question is from steady state analysis of sinusoidal signal. Steady state analysis. First question on a very basic thing, that is the nodal equation. Then this one, in the given circuit, for maximum power to be delivered to RL, maximum power to be delivered to RL, its value should be, what should be the value of RL? Now it is maximum power transfer theorem, the steady state analysis of for sinusoidal signal. What we are doing, this is the black box. This is RL. You can convert it into ZTH, JXTH, this is RL, and you can find this VTH. Okay, then what should be the value of RL? RL should be equal to what? Mod of ZTH for maximum power. You have to find the mod of ZTH, but before that you have to find what? ZTH. What is the value? Everyone give me the answer in comments box. Now how we can find the ZTH? Then to find the ZTH, first of all, you have to make this voltage source 0. And then watch this. What is the omega here? 1K radian per second. So what is the impedance because of the inductor? J omega L. It will become J, 1K means what? 10 to the power 3 into 4 into 10 to the power minus 3. And that will become J4 ohm. J4 ohm. This is J4 ohm. Now what is the, because of the capacitor, Zc is equal to 1 by J omega C or minus J by omega C. So what is the omega? 10 to the power 3, 1 kiloradian. And what is the value of the C? 0.5 millifarad. 10 to the power minus 3. This is cancel out, and 1 by 0.5 is nothing but 2, J2. So Zc is J2 minus J2 ohm. Now how we can find the Thevenins here? This will act as short circuit. So what are the Thevenins? This inductor and capacitor are in series and this resistor is in parallel. This resistor is in parallel. So what is this? J4 minus J2, and this is the 2 ohm, and that is called ZTH. Now J4 minus J2 is what? J2. So what is the ZTH? J2 parallel with 2. You can write 2 into J2 upon 2 plus J2. You can take 2 as a common, then it will become J2 into 2 upon 1 plus J. This 2 cancel out. And then guys, what is this? The magnitude of this is root 2 and angle is 45. You can find ZTH. 1 minute. Okay. So what is the ZTH is equal to J2 upon root 2. J2 upon root 2, and what is the angle here? 45 degree, but only the magnitude is required. Angle is in denominator, the angle is what? 45 degree. This is nothing but angle is 45 degree, but only the magnitude is required. And because of this G, angle is what? 90 degree. So 90 minus 45, total angle is 45 degree. So what should be the value of R mod of ZTH for maximum power, that is the root 2 ohm. This is the answer. This is the answer for this particular question. Now next question, next one. Okay, tell me what is the answer for this one. For the network shown, the equivalent Thevenin's voltage and Thevenin's impedance as seen across terminal AB is. As seen across terminal AB is. Tell me what will be the answer. Okay, now for the network shown, the equivalent Thevenin's voltage and Thevenin's impedance as seen across the terminal AB is. Here you have to find the Thevenin's equivalent. What is the Thevenin's equivalent? Now this is 2 ohm, 3I1, this is I1. Thevenin's equivalent means what is given in the answer MCQ. 50 volt in series with 2 ohm, 65 volt, 35 volt, 10 volt, everything. Means you have to find the voltage as well as what? Resistance. So voltage as well as resistance means, first of all, what is the open circuit voltage? VOC. What is the VOC? There is no current in this branch, I is equal to 0. That's why it is called open circuit. Now, in case of open circuit, this 5 ampere will become I1 because this current will flow through this. So what is the value of I1? 5 ampere. Now, you can write a KVL in this loop. So what is the VOC is equal to 3I1 plus 10 times of I1. It is 13 times of I1. And what is I1? 5 ampere. It will become 65 volt. VOC is 65 volt. First of all, check what is given in the answer. You will check where is the 65 volt, only in one option. That's why this is correct. No need to find the RTH. Why we are wasting your time in exam hall? Simply put the value 65 volt, right? And that is the value. Now, what is the resistance here? Resistance you can find by, now once you have find the value what? VOC, then what is the ISC? ISC. Now this current, watch this. This is 5 ampere, this is I1. So what is this? 5 minus I1. So ISC is nothing but 5 minus I1. Now you can write a KVL in this loop. When I am writing the KVL in this loop or in opposite direction, this is minus 3I1 plus 2 times of 5 minus I1 minus 10 I1. This is the KVL. Now you can write minus 3 I1 plus 10 minus 2i1 minus 10 is equal to 0. 3 plus 2, 5 minus 10, 15i1 is equal to minus 10. What is the i1 is equal to? Minus minus cancel, 10 by 15. That is 2 by 3. Now, what is ISC? 5 minus I1. 5 minus 2 by 3 means you will get 15 minus 2, 13 by 3. 13 by 3 ampere. Now, what is the RTH? RTH is nothing but VOC upon ISC. VOC upon ISC. What is the VOC? VOC is 65. So 65, 13 by 3, it will become 5 into 3, that is the 15 ohm. So already that answer, one answer is correct. That's why no need to calculate the second one, and that is the 65 with 15 ohm in series. The B is the answer. Now, if only RTH is asked, then you can use one. Any student can ask, sir, can I directly use that? What is this formula? We are connecting a 1 volt battery, external battery, and we are finding the RTH. Yes, that is applicable in case of what? If only the RTH is asked, or otherwise you can also use 1 volt battery. Like this is the current I. But remember, in this method, you have to make all the independent source 0, means this current source will act as open circuit. Now, I1 is nothing but I. I1 is nothing but I, and write down the KVL here. 1 is equal to 2I, 2I1, because I1 is equal to I, plus 3I1 plus 10I1. So I1 is equal to what? I. That's why it will become 15I. What is the 15I is equal to? What is the 1 by I? 1 by I is equal to 15. That is nothing but RTH. Then it will become 1 mark question only. Then it is a 1 mark question only. Okay, Supriya, how are you? With dependent sources. And you have to make the independent sources is equal to what? 0. Independent sources is equal to what? 0. That is the method. Okay. So this is a direct method. And this is what it is visible. I is equal to what? I1, or I1 is equal to I. You can write a KVL and you can find the 1 by I, that is called RTH. Now, next one. What the level of question in 2021, so that you will get idea what would be the pattern in coming exam and so on. In the circuit, switch S is in the closed position. Where is the switch S? Here. S is in a closed position for a very long time. If the switch is opened at time t equal to 0, then ILT in ampere for t greater than 0. Exactly, the switch is open, then what is the I current through the inductor? Initially the switch is closed, right? It is closed in a very long time. If the switch is open, then if suppose it is closed, guys, then this battery is short circuited, then what is the finally the inductor under steady state inductor act as what? Short circuit. So what is the initial current through the inductor you have to find, and then you have to find the current for the inductor for t greater than 0. Then how we can solve this question? Watch this. First of all, to get the equation, we have to use IL is equal to what? I final minus I final minus I initial e raised to power minus t by tau. That will be the equation. Okay. Now, initially the switch was closed. When the switch was closed, it will short circuit this path. Then this is the 10 volt battery. What is the voltage at this point? 10 volt. What is the steady state current through the inductor? Exactly at t equal to 0 negative, just before switching, circuit is in steady state. Steady state. When the circuit is in steady state, then what is the IL 0 negative is equal to IL 0 positive, because inductor acts as short circuit under steady state. 10 divided by 1, 10 ampere. 10 ampere. Okay, that is the initial current through the inductor. Right answer. Now the switch is open. When the switch is open, remove this switch. This is the 30 volt, this is the 10 volt, these are in the series. 30 plus 10, 40 volt, 4 plus 5, exactly at t equal to infinite. Again the inductor will act as short circuit. What is the final current? 30 plus 10, 40 divided by 5, 8 ampere. This is the final current. And what is the time constant? Always remember we are calculating time constant for t greater than or equal to 0. Now the switch is open. Find the time constant. Time constant is L by R. What is the R? 4 plus 1, 5. And what is the L? 0.2. 0.2 divided by 5. 0.2 is nothing but 1 by 5. So it will become 1 by 25 second. This is the time constant. 1 by 25 second. This is 4 plus 1, 5, and that is the value of L. Now you have the final value, you have the initial value. What is the final value? 8. What is the final value? 8 minus initial value is 10. E raised to power minus t by 1 by 25. It will become 8 plus 2 e raised to power minus 25t ampere for t greater than or equal to 0. 8 plus 2 e raised to. Is there any answer? Okay. What was the value of the inductor here? 4 plus 1, 5. And I think I have written right now L by R. This answer is correct, but the time constant. What is the time constant here? 0.2 divided by 0.5. Yes. Okay. L by R. Okay, I think everything is fine. There may be chance that calculate. Okay, so what is the method here? Just we will discuss the method here. First of all, switch is closed. Find the initial value of the current. Inductor under 0, circuit is in steady state. Therefore, inductor for DC always remember act as short circuit under steady state, right? There may be chance that options is wrong, and that's why. Second, find the initial voltage, initial current through the inductor. Now, switch is open, and this formula I final minus I initial e raised to power minus t by tau. Then again under steady state means not this time the steady state will switch open exactly at t equal to infinite. Again the inductor will act as what? Short circuit. And that is that in this way you will get the final value. And always remember we are calculating the time constant for t greater than 0. So what is the L equivalent? 4 plus 1, 5. And what is the R L is what? 0.2. What is the R? 4 plus 1, 5. And that is the value. Okay. So that is correct. Now, next question. This one, the input impedance for the network shown in the figure. Input impedance for the network shown in the figure. That dot convention is given. This is the 4 Henry, this is the 5, this is 6 Henry, and this is the mutual inductance M. Mutual inductance M. This is self inductance L1, this is self inductance L2. And you have to find what is the input impedance for this. We have the standard formula for that, but if you have, then you can directly use. Otherwise, just I am giving you the hint how we can find the question, solve the question. First of all, what is the input impedance? Suppose this is the I1. And this is V1. This is V2. And this is I2. You can choose any direction, I1 or I2, in opposite direction or in this direction or in that direction. Now, what is the Z input is equal to V1 upon I1. V1 upon I1. Then you can draw the equivalent circuit of this. This one. This is SL1. What is the L1? S6 ohm. This is 1 4 ohm. That is in frequency domain I1, and this is V1. And now here you are using J omega M I2. So J omega M is nothing but SM I2. SM I2. Then what about the polarity? Just I will give you the idea that second, this will become SL2. What is the SL2? 4S. And this is remain 5 ohm. And then this is I2. This is I1. And then this will become SM I1. Now what about the polarity? Watch this. When the current enter into the dot, for example, it is enter into the dot, this side will become plus, this side will become minus. This is plus, this is minus. Above it is plus, if it is minus. This is the effect of I1, right? Now, okay, Sayyid. So what means that question is correct, na? That question is correct. If it is 0.5, then you will get the right answer, okay. Then this is the 5. And second, watch this. If the current leave the dot, for example, here, current enter through the negative through the coil and leaving the dot. When it is leaving the dot, dot will become negative and this will become positive. So this will become negative and that will become positive. Now, first of all, write the KVL in this loop. So what you are going to write? I2 into 5 plus 4S minus SM. What is the M here? M is 1 Henry. SI1. M is 1 here. SI1 is equal to 0. Just I have written the KVL in this clockwise direction. You will get this. So what is the I2 in terms of I1? You can say I2 is equal to S upon 5 plus 4S into I1. This is the I2. Okay. Now, write down the KVL here. When I am writing the KVL, so what is the V1 is equal to 4 plus 6S I1 minus S. What is the M1 I2? Now you can put the I2 from this side in terms of I1. It will become 4 plus 6S I1 plus minus S square 4S plus 5 I1. Now I1, V1 by I1 is nothing but Z in, and now you can arrange it. When we are going to arrange it, 4 plus 6S, 4S plus 5. And watch this, minus S square, and that is equal to V1 by I1 Z in upon 4S plus 5. Okay, then you can multiply 16S plus 20 plus 24S square plus 30S minus S square upon 4S plus 5. Then it will become 24 minus 23S square plus 46S plus 20. Calculation is your part, but that is the way. In this way we can solve this. What is the answer? 4s plus 5 in denominator. So 4s plus 5 in denominator means here, but 23s square. This is the answer. 46, 20, 46, 20, 23, here 25. Means there may be the chance of what? Silly mistake, plus or minus sign. That answer will become wrong. Okay. So in my class, I have given the shortcut for this directly. You can use in terms of what m, but you have to recall. Otherwise, if it is not possible to recall the formula, then directly you can solve like this. That is called dot convention. First of all, draw the proper equivalent diagram and then find what? This Z equivalent in terms of what? M, in terms of what? Omega square and so on. The input impedance formula. What is the what is the actual impedance seen by the V1 because of this coupling? Okay. Now dot convention. Now next one. Before next question, guys, you can give the scholarship test on this Sunday on 8th of October, right? Okay. And this is a golden opportunity for you. National scholarship test, get up to 90% off on our program. The window will be open from 9 a.m. to 9 p.m. Then get up to off, and this is the golden opportunity. If you are giving the exam, then you will get the idea which is your strong point, which is your weak point, and so on. Okay, to register now for this, and already we have started the crash course. You can join. Second, is it possible to cover GATE 2024 syllabus timely? Because we have only 4 months, October, November, December, January. So that is a workshop by Abhinav Negi sir, 11th of October at 7:30 p.m. You can register here for this workshop. And if you find any difficulty how to make the schedule, how to make notes, short note, detailed notes, what is your revision plan, each and everything will be discussed here. So you can join here. This is the very, very important workshop for you. Now guys, 2022. What are the 22? Okay. Supriya, I will explain that one in what I can arrange one session for that. Dot convention. Dot means what? Mutual inductance. So where we will discuss around what? 10 questions. Because I am taking what? Power of 10 series. So what is the meaning of the power of 10 series? Means suppose you want to get the command over something, right? Some topics. So how we can get the command over that topic? Suppose mutual inductance. If just theory, and if we are solving the around 10 questions, easy, moderate and tough, automatically you will get the command over that particular topic. Okay, and that's why I have started power of 10 on YouTube, and this time I am going to discuss what? Filter by using the operational amplifier, where we will discuss different types of filter. All pass filter, band pass filter, band reject filter, high pass, low pass, all questions on filters, right? And then what? 10 questions on multivibrators. Multivibrator means bistable, monostable, astable, symmetry trigger circuit, square wave generator. So automatically you will get the command over those topics. Okay. Now the transfer function of a real system Hs is given as As plus B upon S square plus Cs plus D, where A, B, C, D are positive constant. This system cannot operate as low pass filter, band pass filter, and integrator, or what? High pass filter. Right? Now which answer is correct? Tell me. Which is the correct answer for this particular question? Band pass filter, or what? An integrator, high pass filter. Okay. Right. See, you are saying that band pass filter. Now watch this. As plus B upon S square plus Cs plus D. Okay. What is the transfer function is given? As plus B upon S square plus Cs plus D. Right. First possibility. Watch this. If B is 0, or let A is also 1 or anything, it will become S upon S square plus CS plus D. According to control, what is this S? So what is the initial slope? Initial slope is 20 dB per decade. Why? Because we are having 1 0 at origin, 20 volt per decade. Then we are having the 2 zeros in denominator. There are 2 poles in denominator. Because of one pole, it will decrease by 20 dB. And because of another pole, it will become minus 20 dB. So tell me which type of filter it is. Which type of filter? Band pass filter. Yes, it is possible to design the band pass filter by simply what? Making the B is equal to 0, and that is a 1 0 at the origin. Yes, you can design the band pass filter. Now, for low pass filter, simply make S is equal to 0. It is nothing but second order low pass filter. So exactly at omega is equal to 0. Omega 0 means this is what is the magnitude. J square omega square, this is the S square, means plus J omega C plus D. When we are making the omega equal to 0, the gain is what? B by D. And exactly at omega equal to infinite, the gain is 0. It is a low pass filter. It means it is possible to design the low pass filter. But it is not possible to design the high pass filter, because exactly at infinity, what will be the gain? It will become 0. But for high pass filter, exactly at infinite, the gain should be what? Finite, constant. And that's why we can't design the high pass filter. Okay, that is a high pass filter. Now, what is the last option? An integrator. With the help of what? Low pass filter, we can design the integrator. Integrator is under special condition, low pass filter can be converted into what? Integrator. So that is it is also possible. That is possible. That is also answer is what? High pass filter. Now, just I am giving you the hint that second order RLC circuit. That is the signal we are giving. Okay. Now we can design different types of filter from this. Tell me guys, what is this? Which filter? Tell me. If we are taking the output across C, then second, if we are taking output across L, okay, then tell me first one which filter, second one which filter, third, which filter? We are taking output across R, L and C are connected here. This is the third one, last. Right? This is L, this is C, this is R. Now, this one, first one, is a low pass filter if we are taking output across the C. So this is a low pass filter, second order low pass filter. If we are taking the output across the inductor, then it is become high pass filter. Now tell me, what is this? Band pass filter or band reject filter, and what is this? Band pass. So everyone please write in comments, what about the third one, fourth one? One is what? Band pass filter. One is what? Band reject filter, band stop filter. Which one is the band pass filter and which one is the band reject filter? And under resonance, the series combination of inductor and capacitor act as short circuit or open circuit. You will get the answer. So under resonance, the series combination of inductor and capacitor will act as what? Short circuit. When it is short circuit, so what is the output voltage under resonance? Right? And now exactly at T equal to omega equal to infinite or omega equal to 0, one of the element will act as open circuit. In this way you can design what is this circuit, what is this. Okay, please give me the answer in comments box. Next question. Next one. An inductor having a Q factor of 60 is connected in series with a capacitor having a Q factor of 240. The overall Q factor of the circuit is, what is the Q factor of the circuit, everyone? What is the Q factor of the circuit? You have to find what geometric mean of that. 60 and 240, find the geometric mean of that. You will find the quality factor of the one inductor having a Q factor of 60 is connected in a series with a capacitor having a Q factor of 240. The overall Q factor of the circuit, you will get the answer for this particular question. Root over 60 and 240. Okay. Then this is a 1 mark question only. You can find, use your virtual calculator and you can find. Then next question is, in the circuit shown, the switch S is closed at t equal to 0. Where is the switch? This is the switch is closed at t equal to 0. The magnitude of steady state voltage across the 6 ohm resistor. This is a very simple question, 1 mark question. What is this? What is this? Tell me. Then tell me, guys. In the circuit below, the switch S is closed at t equal to 0. The magnitude of steady state voltage means capacitor will act as open circuit under steady state condition for DC voltage. For DC voltage, capacitor will act as open circuit. Once the capacitor will act as open circuit, now this particular branch is open. When this particular branch is open and it is asked, what is the voltage across the 6 volt resistor? What is the voltage across the 6 volt resistor, that is asked. Means very simple one. This will act as open circuit. Now you have to 6 parallel with 3 is what? 2 volt. And this is 2 ohm. 2 ohm, 2 ohm. 2 ohm, 2 ohm in series. Voltage will divide. What is the voltage across this 2 ohm? 5 volt. What is the voltage across this 2 ohm? 5 volt. This 2 ohm is nothing but parallel combination of 6 and 3. So what is the voltage across this 6 ohm? 5 volt. Quickly you can. And now watch this. This is in 2021. Right? 2021. Now what is the problem here? Printing problem. In the circuit shown below, the magnitude of the voltage V1 in the voltage across the 8 kilo ohm resistor. I have to redraw the diagram. What is the problem here? 1 minute. Every question there is problem? No, only one in this one question. Okay, no problem. This is 2 kilo ohm. .5 V1. Okay, and that is I. .25 volt. This is I. And that is the question. So what is asked here? In the circuit shown below, the magnitude of the voltage V1 in volt across the 8 kilo ohm resistor is. Across means you have to find the V1. V1 means it is a dependent source plus minus. There are two dependent sources. One is I, one is what V1. And how we can find a V1? Watch this. If you want to find I, what is the I here? First of all, I is nothing but this is the current passed through the 8 kilo ohm resistor. So what is the relation between the V1 and I? 8 into I is V1. 8 into I is V1. Okay. Then you can write a KVL here. When I am writing a KVL here in this loop, then it will become 25 is equal to 2I plus 0.5 V1. You have to find V1. So what is the V1? 25 is equal to I is equal to V1 by 8. You can write 2 into V1 by 8 plus 0.5 V1. And that will become 25 is equal to 1 by 4 plus 0.5. So this is the 0.25 plus 0.5 V1. What is the V1 is equal to 25 divided by 0.75. 0.75 is nothing but 3 by 4. 100 by 3 volt. 33.333. If it is 25 volt, then 75 in this question, okay, no problem. You can put 75 here. 75. What is the 75? Then it will become 100 volt purely. That method will remain same. This is in place of 25, you can put the 75. Yes, no problem. If it is 75, then this is 25. In place of 25, put the 75 and you will get the answer 100. Okay, that is clear. Then no need to write it. Okay. Now it is the answer, Sayed. Okay. Now next one. Next question. Now guys, this is the leaderboard. You have to download the BYJU'S exam prep app from the Google Play Store, and then you can solve questions through what mock test. Okay. So first of all, install the BYJU'S exam prep and try to attend the regular free classes available. Once you will give the mock test or quizzes, that it will show you the leaderboard, number of participants, what is your rank, what is your score, each and everything. Okay. And that is a very, very important platform for you. Just you can start giving the quizzes. Then next one, 2023, question from 2023. On various topics, we will solve question, don't worry. Just I have to arrange one more session on that. So where we will cover topics like what different network, other than what two-port, transient, KCL, KVL, mesh analysis. Okay, so here we are covering this topic and steady state analysis. Basics of the network, two-port, transient, steady state analysis of sinusoidal signal we are covering. Now, continuous time system that is initially at rest is described by where xt is the input voltage and yt is the output voltage. The impulse response of the system is, what is the, which answer is correct? Impulse response of the system is. Okay, this is a very, I think it is a very easy question now. Tell me what, which answer is correct? Impulse response. Continuous system that is initially at rest. Initially at rest means what is the initial value? 0. Then what is the Laplace of this differentiation? SYS plus what? 3YS is equal to xt is the impulse, and what is the Laplace of the impulse? 1. Laplace transform of the impulse is what? 1. Okay, and that's why it will become 2 only. Now what is the ys? 2 divided by s plus 3. What is the Laplace inverse of this? 2 e raised to power minus 3t. 2 e raised to power minus 3t means this answer is correct. D is the correct answer for this particular question. Okay, next. Okay, the value of the parameters of the circuit shown in the figure are R1 is equal to 2 ohm, R2 is equal to 2 ohm, R3 is equal to 3 ohm. Where is the R3? This is the R3 is equal to 3 ohm. L is equal to 10 millihenry and C is equal to 100 microfarad. For time t less than 0, the circuit is at steady state with the switch K is closed condition. This is the switch K is closed condition. Under steady state, if the switch is opened at t equal to 0, the value of the voltage across the inductor at t equal to 0 positive in volt is. You have to find the voltage across the inductor. What is the answer, everyone? Give me the answer for this question. Now, watch this. Under steady state, when the switch was closed, and what is written here? Switch is opened at t equal to 0. Means when the switch was closed, circuit is under steady state. Switch is closed and circuit is under steady state, then inductor, for DC inductor act as short circuit, capacitor act as what? Open circuit, because it is a 10 ampere DC. This is inductor act as short circuit, this capacitor will act as open circuit, then this is short circuited. This is R1, that is R3. What is the value of the R1? 2 ohm. What is the value of R3? 3 ohm. According to current division rule, what is the current through the 2 ohm resistor here? Because it is open circuit, there will be no current through the capacitor. This current will divide into 2 parts. So what is the current here? I2. I2 will become 10 divided by R2 plus R3. R1 plus R3 into R3. 10 into 3 divided by 2 plus 3. That will become 6 ampere. And this current will pass through the inductor. When this current will pass through the inductor, remember, inductor does not allow sudden change of current. And that's why, what is the initial current through the inductor? 6 ampere. Now, what is the voltage across this? Because this is nothing but the voltage across the capacitor. Drop across the I2 is 0. So 6 into 2, that is the 12 volt. VC0 negative is equal to VC0 positive is equal to 12 volt. Capacitor does not allow sudden change of voltage. So first of all, find the initial voltage across the capacitor and what? Initial current through the inductor. Now you have the value. What is asked? Exactly at t equal to 0 plus, now the switch is open. What is the voltage across the inductor? Okay. Then exactly at t equal to 0, switch is open. Remove the switch. This part is removed. Now, inductor does not allow sudden change of current. That current will remain same. This is 6 ampere. R1, value of R1 is 2 ohm. Okay. Capacitor does not allow sudden change of voltage. The voltage will remain 12 volt. Now, this is the total current is what? 10 ampere. So 6 ampere will flow here. Then what is the current exactly at t equal to 0 plus? This current is 6, then that's why this current is 4 ampere. Now, what is the value of the R2? 2 ohm. Voltage from this point to this point and voltage is equal to, what is the voltage here? 6 into R1 plus voltage across the inductor is equal to, what is the voltage here? 4 into R2 plus voltage across the capacitor. What is the 6 into 2? 12 plus VL is equal to 4 into 2. 4 into 2 plus what? 12. VC is 12. This 12 cancel, and what is the VL is equal to 8 volt. VL is equal to 8 volt. Okay, please give me the answer. You are getting the same answer. Okay, the capacitor does not allow sudden change of voltage. It will allow the sudden change of current. What was the current? Here the current was 0 because it acts as open circuit. Now it will allow the 4 ampere current exactly at t equal to 0 plus. Inductor does not allow sudden change of current, but it will allow sudden change of voltage. What was the voltage here? 0. Now what is the voltage here? 8 volt. Voltage here is 8 volt. Okay. Now next one. Can you generate the 12,000 volt from the 8 volt battery? 12 volt battery. 12,000 volt from 12 volt battery. Right? If you want to get the idea how we can generate the 12,000 volt from the 12 volt battery, so this Sunday I am going to take one session that is called Learn with Fun session, where I will give you the idea about the spark plug and what is the role of the inductor and how we can get 12,000 volt for 12 volt from the 12 volt battery. We are using bikes or what is scooty and other vehicle where we are generating to ignite the fuel. So how we can get this value? Just you will get the basic concepts and what is the role of the inductor here. Okay. So this Sunday sharp at 7 p.m. Okay. So that is a Learn with Fun session. Subscribe the channel so that you will get the notification. Next question. For the circuit shown in the figure, V1 is 8 volt. Where is the V1? V1 is 8 volt DC and I1 is 8 ampere. This is the 8 volt. The voltage VAB in the volt is. VAB in volt is. What is the voltage across this? VAB. Okay. Now, B means what? Watch this. This is A, this is B, this is also B. This node is also B because this is the B is short circuited. Means this 3 ohm resistor and this 3 ohm resistors are in what? Parallel. Now this is B and you can choose what? This is A, this is B, this is B, and then you can choose any, for example, if you want to write, you can write it what C and that is the D. So there are how many nodes here? Now you can make a proper circuit between, you can put the C and D where 1 ampere current source, then between C and B we are having the one voltage source V1 and the value is given here. That is one way to solve this question, right? And another way to solve this question is what? You can use what? Mesh analysis. Tell me what is the answer for this one. What is the answer for this question? So just this is a very basic question, guys. Right? So we are saying, sir, what about the syllabus? So just we are saying that first syllabus is what? Basics of circuit theory. We are getting the question from the basics. Then we are getting the questions from all the topics, for example, transient. Then we are getting the question from two-port network, steady state analysis. From every topic we are getting the question, that is the theorems and so on. And tomorrow we are going to conduct a mock test at 12 p.m. So you can join that mock test. Now tell me what is the answer for this one. And that is, you can solve this question. This is a homework for you. And give me the answer for this particular question on my Telegram channel. Put the 8 volt here. Remember this node is same B node here. And what is the difference between that node and this node? Already one voltage is given. Okay. That is the V1 is given as 8 volt. Then you can find the value of this VAB. VAB. Okay. The next one. On my Telegram channel means that is electronics by Sanjay Rathi. Now last one. The admittance parameter of the passive resistive two-port network shown in the figure. This is the resistive two-port network. Admittance parameter is given. Y11, Y22, Y12, Y21. What are the Y parameters? 5 Siemens, that is 5 mho, minus 2.5, minus 2.5, and then what? 1. Now, this is the network and one network is connected here. That network is connected in parallel to this. Remember, this is the network that is connected parallel to this particular network, guys. Now, when it is connected parallel to the network, then what is the Y parameter for this 3 ohm resistor? So you can find the Y parameter for this first of all, so that you can find the overall Y parameter. So one for this network, Y parameter is known, and then these two networks are connected in parallel. So this is let A network. This is A network. Now what is the Y parameter for the second network? Then this is 3 ohm. You can write 1 by 3 ohm more. You can convert. This is nothing but YB. Let this is the pi network. What is the YA? If it is open circuit, it is 0. What is the YB? YC, it is 0. So what are the Y parameters for beta network? YA plus YB. So YB is 1 by 3. Minus YB. Minus YB. YB plus YC. 1 by 3, 0. Once it is open circuit, admittance parameter is 0. Impedance is what? Infinite. So this is the 1 by 3, minus 1 by 3, minus 1 by 3, 1 by 3. What is the overall Y parameter? YA plus YB. So what is the YA? 5 minus 2.5 minus 2.51. 5 minus 2.5 minus 2.51 plus 1 by 3 minus 1 by 3, 1 by 3 minus 1 by 3, 1 by 3. Okay. Then you can add, this will become 16 by 3 minus, this is the minus, this is the 0.333, or directly you can add, or 2.5 is what? 5 by 2 plus 1 by 3. And again this will become also 5 by 2 plus 1 by 3. Okay. Then 1 plus 1 by 3, that is 3 plus 1, 4 by 3. Okay. So this is the value. Now 17 by 3, this is nothing but 17 by 15 plus 2, that is the 15 plus 2, 17 by 3. Okay. Then what is asked here actually? The admittance parameter of the passive network, the power delivered to the load resistor RL in watt is, what is the power? 20 volt DC. You have to find the current here only. What is the current through the RL? Then the power will become I square RL. So this is I, or here you can find this is called I2. This is called I1. This is V1. That is V2. Or there are two ways to find the power, V square by RL or I square into RL. Now you have the Y parameters, overall Y parameters, then you can write the equation I1 is equal to Y11 V1 plus Y12 V2. Okay, and what is the I2 is equal to Y21 V1 Y22 V2. Now how we can find the I2? For example, Y12 is given, this is the I1, V1 is 20 volt, watch this. What is the V1 here? 20 volt, and R1 is 6, RL is 6. This is given as 20 V1. You can put I1 is equal to Y11, you know, 20 volt. You can put Y21, Y12. You know the value of the Y12. And in place of V2, you can write minus I2 into RL. RL, what is the RL? 6 ohm. RL is 6 ohm. And this is the, what is the V2? V2 is equal to minus I2 into 6. Now, the complete equation, Y11 we have the value, Y12 we have the value. Now you will get the relation between I1 and I2. Put the value of right? Once you have, and now directly you can also use this equation. Why you can use? Because we have want to find I2. So what is the I2 is equal to 20 times of Y21. We have the value of the Y21 plus what? Y22 we have the value, and you can put minus I2 into RL. That is the 6. And from this directly you can find the value of what? I2, and then you can find the power here. So what is the I2? This will become I2 1 plus 6 times of Y22 is equal to 20 times of Y21. So what is the I2 is equal to 20 Y21 upon 1 plus 6 Y22. What is the value here? Y21 and Y22. Y21 minus 1 by, this one. Y21, this is the 17 by 3, and Y22 is 4 by 3. You can put here 17 by 3 and 4 by 3. Now, once you will get the I2, then you can calculate the power here. What is the power? I2 square. It doesn't matter whether it is positive or negative. I2 square into RL. And that is the power delivered to what? RL. So that is the way. So now, when we are solving, just focus what is required here. For example, I am just giving you the equation. If suppose I1 is required, what is the input impedance is required? Then input impedance means what? V1 upon I1. V1 upon I1. In that case, we can use this equation. Otherwise, you can use this equation to find the I2. This is important equation. This one is required because V1 is directly given 20 volt. Okay. So that is this type of questions from the, to watch the level of question. It will boost your confidence. 21, 22, 23. Because last 3 year means latest pattern. Numerical answer type, MCQ and MSQ. And then in next session, I will cover the question from electronics. Stay tuned with me. I am taking the power of 10 series. And that is the crash course for you 2024 crash course. Complete syllabus coverage for electronics and for electrical branch. For more detail, you can call at this number. Okay. Live classes, recorded lectures are available. Study material, practice quizzes, mock test, everything. तो चलिए स्टार्ट कीजिए अपनी जर्नी हमारे साथ, और आप 4 महीने में भी इस एग्जाम को क्रैक कर सकते हैं. This is my Telegram channel. You can join for PDF of this session, that is Electronics by Sanjay Rathi. Okay. Thank you for attending the session. You are on BYJU'S exam prep. Like the session, share the link of this session and subscribe our channel, guys. Thank you.